So let's look at another example of a power series. So far we did one that had a finite interval. And then we looked at one that was convergent for all reals, which is really ideal. And let's look at the other extreme where it's really not much good at all, and that it only converges at its center. Remember, we know every power series will converge at least at its center because it's trivial. If you plug a -2 into there, all the terms are 0. So, or at least all the terms except for the n equals 0 term. So let's look at what happens when we apply ratio or root test here. There's a factorial, so that's pushing us towards ratio test. So let's set up our row. Limit as n goes to infinity. Set up our ratio in absolute value. N plus 1 factorial, x plus 2 to the n plus 1 over n factorial x plus 2 to the n. That simplifies down nicely. Just n plus 1. Now actually, the bottom is just, everything's going to cancel off, right? The n factorial is gone, leaving the n plus 1 here. I guess I didn't really even need to write a fraction. That's OK. Now remember, this is a constant, so I'm going to take it out front just so we can think about this a little easier. So we have that constant out front times this limit. Now, what is that limit equal to? Well, this thing is headed to infinity, right? N plus 1 is going to infinity. So this gets larger and larger and being multiplied by some constant, some non-negative constant. Then it would just go to infinity, right? But if every term in here, and actually it might be easier to think about it now that I think of it, to go ahead and let's actually leave it inside there. I'm going to rewrite this just so we're clear. Let's keep that app, even though it doesn't have to be in there. It might be easier to follow the idea. So let's just think about the terms. So as n gets bigger and bigger, let's go with x being -2. So if we're at the center, if x is -2, the first term of this sequence is 0, because it's 0 times 2. The next one is 0 times 3, then 0 times 4, then 0 times 5. Every term in the sequence is 0. So in the one case, this limit is 0, provided x is -2. But what if x is not -2? Well, if x is not -2, then this is non-zero constant, and it doesn't really affect the limit, because then this is going to infinity, and you're multiplying it by some non-zero positive number. So it's going to go to infinity. So what do we see? We see that really the only thing that's going to make this series converge is its center, x equal -2. That's the only time that this row is going to come out to be less than 1. So in other words, row is less than 1 only for x equal -2. Otherwise, it's bigger than 1. It's infinity. So our power series converges absolutely for only for that single value. There's only one value you can plug in that makes it convergent. So there's no conditional convergent because there's not really any endpoints. And you could say, since there's no real interval, the radius of that interval is 0. And now that I'm thinking about it, when I did the example where we were all real numbers, I didn't write r, but we would just say r is infinity in that case. So when you have all reals, it's infinity. When you only have the center, r is just 0, because there's no width, because there's no real interval. It's just a dot. It's a single point The center is the only place it's convergent. This would be a power series we would not be very interested in because it's non-existent for almost every value you plug in, and the only time it does exist is for a trivial case of its center.